My name is Zeshan Delou. I work for Bioversity International. If you can't hear me, please yell up. Normally I have a very soft voice, so I try and speak up loudly. It's a pleasure for us to be here to make this presentation at the FAO Study Circle on Climate Change. Bioversity has been working for a long time now on this aspect, and would like to share with you today some of our thoughts and our approaches on how we can help farmers cope with climate change. So this is going to be a dual presentation. Me and Paul Bordoni, my colleague at Bioversity, which were both of us are working on different projects, but it really complements each other very well. So we are doing a joint presentation for you. So what we are hoping to do is first to very quickly put it into a context on how climate change is affecting agriculture. And then telling you a little bit of our concept of seeds for needs, as we are calling it, and how seeds can be utilized to meet the needs of poor farmers in particular. We'll describe a little bit some of the different climate change research that Bioversity is undertaking. We'll talk very much about farmers and from their perspective of how they are seeing climate change. And finally, we'll give you a quick overview of some of the new consortium research program of the CGIAR on climate change, agriculture, and food security, in particular those themes in which we are mostly engaged in. Well, as you all know, climate change is going to have a major impact on agriculture and on the livelihoods of people, particularly the poorest farmers, those are living in the marginal environments particularly. And as you know, it's going to be a big challenge because we'll need to increase food production at the same time by 70%. For the 9 billion people that is coming. So at one hand, we have to increase production. On the other hand, climate change is going to make that even more difficult. So the challenge is rather a big one. And to make it even worse, there is so much uncertainty about how climate is going to change. The impact that it will have will be different in different locations. We don't know exactly how it's going to impact itself over time, how quickly it's going to happen. There's a lot of models that have been developed, as you know, but a lot of those models contradicts each other, so which makes us prediction for us to know what sort of strategies to develop very difficult. So we have to rely on this uncertainty and work with that. Also, it requires a lot of uncertainty for farmers themselves to cope with climate change. Very recently, we heard from Madagascar, from a farmer, I think Jean-Jacques Adrianaivo, who, as you know, Madagascar, they are growing vegetables and rice as their major staple food. Normally, the rains comes in the middle of December, and they plant their seeds a little bit before that to catch the rain. And this year, the rain has come very late. It only came in the middle of January, last January. So what happens is that they have these canals which brings water to their fields. In the past, there was always enough water for them to irrigate their fields. Then for the very first time, these canals became dry because the rain was late and there was not enough water. And this year, it was even more different. There is no water at all because the rain came so late for them to do. So the soil became cracked and their crop failed. So this is a very nice example to show the impact that climate change can have on crop production and in particularly for these poor farmers there. So the impacts that we know, the projected impacts of climate change, that there are going to be increases in extreme weather conditions. We are seeing this in the news every day. Floods in Australia, drought in Madagascar and elsewhere. Temperature is going to increase and there will be changes. This will have impact on the changes in the growing season. Farmers will need to cope with this. not talking about the impact that this will have on the distribution of new pests and diseases. They are also going to move with this climate change. So again, the farmers will be forced to shift the type of crops they are doing. There will be shifts in areas which are suitable for cultivation of particular crops. So if these impacts are not addressed, the nutrition and the livelihood of many of these poor farmers will be compromised. So production costs will increase. There will be also cost in terms of disaster management. The risk that you have will also increase. So it's a big task. So what we are proposing is this concept, the seeds for needs. The basic premise for this is that farmers, with these changes that will happen, farmers will need access to more drought-tolerant or heat-resistant or disease-resistant varieties in order to produce some crop that they can use to feed their families. So that's basically the premise from which we go. And we believe that gene banks collections, as you know, gene banks are a collection of seeds that have been collected from the wild for many, many years and conserved in gene banks. These collections can provide pre-adapted seeds because they've been collected all over the country. We know from the FAO State of the World report that there are now 7.4 million accessions in the World Gene Bank. So this is an enormous reservoir of diversity that we have there at our disposal to make use of. And that's not counting all the traditional collections which are conserved by the farmers themselves in traditional systems. So all these collections harbors a great resource of diversity that can be used to harness particular traits, climate, adapted traits or tolerances to various environments, and can be deployed directly to farmers or even to breeders to develop climate-ready varieties. And we at Bioversity, we are also developing an information system that will make easy for us to identify these traits of value to farmers. So what I've spoken is one side of the coin, and this is the diversity which is present in the gene bank is only a limited one. It's like the tip of the iceberg. But then the iceberg itself lies in the field in situ, and I'll let Paul to tell you a little bit about diversity there.
Yes, thank you, Eshan. And so I'll step in just briefly to make the point of the importance that the agro-ecosystem has as a provider of resources, material, and services to the farmers, and the importance of diverse systems in providing these services. So this picture illustrates a farming system in Thailand, in northern Thailand, where they are practicing rotational farming. But the important part is as you can see the picture on the left, it shows you how the landscape is divided into various different components. There's a flyer that is depicting this situation. And that tells us about the importance of having all different bits and pieces that work together in an integrated way to provide services to farmers. So the important part here for us is to mention the wild and uncultivated landscape that provides resources and interacts and borders with the farm, and that there is an exchange of materials, and this is very precious to maintain. No? So a source of material. So
yeah, this is very much a complementary way of where the diversity is being conserved in situ in the ecosystem, both in the wild and also on the farm, in the agricultural system, where farmers have been selecting varieties over generation and generation and evolving with the pests and diseases there, with the abiotic environment. So it's very complementary to the gene bank activities. So what I like to go through now is to tell you a little bit how this seeds for needs concept works. How do we actually identify the accession that might be useful to the farmer? Let's take, for example, barley in Ethiopia, in gene bank. So we are going to have, we want to select, which accession from the gene bank there that might be useful for the farmers to cope even presently or in future climate change scenarios. So the first thing we do is that we plot the places where those accession has been collected. So we get a distribution of where the various accession has been collected in the country. Now this information may come not only from the Ethiopian gene bank but from any collections elsewhere in the CGIAR centers. So as long as we have good passport georeference data, we can make these plots. And then we decide, okay, we need these accession that might tolerate an annual mean temperature of above 20 degrees. So the blue areas there, you see, will start to recede, and also which has an annual precipitation of less than 1,000 millimeters. So then you can select those areas where the blue areas where the accession that matches with the blue areas could be or even here where we have an annual range between 22 and 29 degrees. So then you can select a few accession that would sort of meet these requirements. Or else you can look at some of the traits which are important to farmers, such as for barley, the scald disease is an important one. So you can look at where plot the susceptibility to the disease with the where the accession come from in terms of view from the temperature, for example, and then you would select those accession that are originating maybe from the hot climates and have a low susceptibility to the particular disease. Now this is just for illustration, but it shows you the concept on how you can use a geographic information system to identify particular accession that meet particular needs of the farmers, but also that is adapting to future climate change. So Bioversity, then, what we are doing is our research is mainly trying to focus on maintaining and facilitating the use of species and genetic diversity to support adaptation to agriculture and other production systems to climate change. I'll describe now a few activities, and Paul will also talk about some of the work he's involved in. We developed a project called Seeds for Needs to promote adaptation to climate change by women farmers in Ethiopia, because we believe also that the gender element, women are extremely important because they are very often the curators of many of the seeds on farm. So they are the one that prepares the food for the family. They are the ones that know what type of seeds they need. And so we would like to focus this activity on them. And this concept was presented to the World Bank Development Marketplace Global Competition in 2009 and was one of the winning proposal, and the project started last year in June in Ethiopia. So what we did was, in the first instance, to do the projection of climate change in the various target region where we were working. And then we developed, as I explained before, the climate profile of these various gene bank accession, and we match the current and even future environmental condition to the target region. The way we did that was to select particular areas along a climatic gradient. And we feel that maybe one of these areas could serve as analog to the other. For example, the high altitude area might become warmer, so it might resemble the climate of the mid-altitude area where we were working. So by testing our accession in these different environments, we might see which accession would become more important in other regions. So that's a little bit the thinking behind it. And obviously, once we've selected, in fact, we've already selected about 100 varieties of durum wheat and barley, and we do participatory evaluation with the farmers on the ground at each of the 3 areas where we are pilot testing this.